In the first part of Unit 2, we were working with fair division. In the second part, we're going to talk about apportionment. And apportionment is the process of dividing a fixed number of discrete objects among groups of different sizes. So an example there would be, what if BCTC had 20 tutors and they needed to divide those or apportion those amongst the different campuses? So because the Lexington campus is much larger, say Newtown is much larger than the Danville campus, we wouldn't want to give Danville the same number of tutors as we gave to Newtown. So we would have to try to figure out a way to fairly apportion them based on how many students were at each campus. And so that's what the concept of apportionment is going to be dealing with. So there's some basic elements we're going to work with apportionment. The first one are the states, and the states refers to any party that has a stake in the apportionment. You could also think of them as the players. We call them the players in fair division. We call them the states in apportionment. The second basic element are seats, and that is a set of M identical, indivisible objects that are being divided among N states. So the states, in our example, would be the campuses, and the seats would be the tutors. So they are the identical, indivisible objects that we're dividing amongst the various campuses. And the third part is the populations. So that is the set of N positive numbers used as the basis for the apportionment of the seats to the states. So in our example, the population would be the number of students on each campus. So apportion is a verb that means to divide and share according to a plan, or to make a proportionate division or distribution. So Ms. Teacher has 50 identical pieces of candy to divide among her 5 students. She says she will divide the candy proportionate to the amount of time each student spent practicing the piano this week. So she's not just going to take the 50 pieces and divide by 5 to give 10 per student. She's going to base it on how much time they spent practicing the piano. So we have a chart that tells us each of the children's names as well as the number of minutes that they spent. So the first thing that we're going to do is we're going to say, okay, well, how many total minutes did all of the kids spend? Well, they spent a total of 900 minutes. So they are going to be entitled to a proportionate share of the candy based on the proportion or the ratio of minutes that they practiced to the total minutes. So you can see we have drawn a proportion here where the ratio of Alan's minutes, 150, to the total minutes, 900, tells how many pieces X of candy that Alan should get out of the total of 50 pieces. And so we end up that Alan should get 8 1/3 pieces. We can do the same thing for each of our other players or students. So Betty would be 78 over 900 equals X over 50, and we would solve for X and get 4 1/3. Connie would be 173 over 900 equals X over 50, and then so forth and so on. So as you can see, each of the students is entitled to whole pieces of candy as well as a piece or a portion or a fractional part of that piece. So the question becomes, if they cannot be cut, how does Miss Teacher decide how many pieces to give each student? And that is the question that we're trying to answer whenever we're looking at different methods of apportionment. So our rules of apportionment say the seats, which are, remember, the assets being divided, in this example candy, can only exist in whole numbers. All seats must be used and no more can be used. So she's got 50 pieces and that's it. She can't give out more than 50. Each state or player must get at least 1 seat. So in our example, at least 1 piece of candy. And the number of seats assigned to each state should be at least approximately proportional to the population of the state. So in our example of the candy, we had one student who was entitled to 8 1/3 pieces of candy, so we should make sure that that student gets at least 8 pieces of candy, and maybe more, depending on how our method works out. So in order to use any of our methods of apportionment, we have some basic definitions that we have to understand. The first one is a standard divisor, and in that case, we're simply going to take the total population and divide by the total number of seats. So in the example of Miss Teacher, the total population would be the total number of minutes that all of the students worked together. With the practiced on the piano together. And then the total seats would be 50 because that represents the number of pieces of candy. So 90 divided by 50 would give us the standard divisor. So then we're going to use that standard divisor to find the standard quota for each state. And that is going to be different depending on the state's population. So if we go back and look at the first student, we take the number of minutes that Alan spent and we divide by our standard divisor. And that is another way of doing the same thing that we were doing with our proportion. It's another way of determining the proportionate number of pieces of candy that Alan should get. And so this one is nice because once we have the standard divisor, we can simply do one division problem to find out everybody's standard quota, as opposed to having to set up a proportion in each case. The upper quota is then the standard quota rounded up. So if Alan's ends up being 8 1/3, that would be his standard quota, and his upper quota would be 9, because if we take 8 1/3 and round it up to the next whole, that would be 9. The lower quota, on the other hand, would be the standard quota rounded down. So for Alan, it was 8 1/3, so his lower quota would be 8. So when we're working with apportionment, just like with most of the things that we do in math, we have to have some method, some set of steps or processes that we're going to follow in order to find a fair proportion or apportionment. So an apportionment method simply refers to a process that will always produce a valid and fair apportionment. Valid meaning that exactly the right number of seats is apportioned, and fair, inherent ideas of fairness to all states. The quota rule says an apportionment method should not apportion a state less than their lower quota or more than their upper quota. So each state should receive either their lower quota or their upper quota. So now that we know some definitions, let's go back and look at our candy example again and talk about apportioning candy for Alan. So the standard divisor, we take the total number of minutes, the total population for all of the states, and divide by the total number of items to be apportioned, or the total number of seats. So in this case, we find out that it is 18 minutes per piece. So in other words, a child should receive 1 piece of candy for every 18 minutes that they practiced. So to find the standard quota for Alan, we're going to take 150, divide by our standard divisor. Note that that is Alan's total population divided by the standard divisor, and we get 8.333 or 8 1/3 pieces. So his upper quota rounds up to 9. His lower quota rounds down to 8. And so whatever apportionment method is ultimately used, in order to satisfy the quota rule, Alan should receive no less than 8 pieces and no more than 9 pieces of candy. So why not just use normal rounding rules to divide the candy? Why do we even need apportionment methods? Well, let's look at our example here, and if we do our calculations, simply take each student's or state's total minutes of practice and divide by the number of seats to be divided, the 50. Then we get that Alan should get 8.33, Betty should get 4.33, Connie should get 9.611, so forth and so on. And we round these using traditional methods. We get that Alan should get 8 pieces, Betty should get 4, Connie should get 10, Doug should get 11, and Ellie should get 16. And notice that that only gives us 49 pieces total. And if you remember back to our previous slide, we said that in order for the apportionment to be valid, it had to award the exact right number of seats. And in this case, 49 is not the 50 that we wanted to award. Therefore, that would not be a valid apportionment because we don't have any way of determining who gets the last piece of candy. So to determine which state or child receives that extra seat, we need to find an apportionment method that maintains proportional fairness and is repeatable. So using standard quotas, there are exactly 435 seats in the U.S. House of Representatives. According to the 2010 U.S. Census, 1.4% of the U.S. population lives in Kentucky, and 8.14% of the U.S. population lives in Texas. So compute Kentucky's and Texas standard quotas in 2010 to 3 decimal places. So the standard quota states the proportional fare of the seats based on population. So equivalently, the standard quota is the product of the population percent and the total number of seats. So since Kentucky has a population of 1.4% and there are a total of 435 seats in the House of Representatives, we can take the population of Kentucky, 1.4, multiply by the 435 seats, and that gives us approximately 6.09 as our standard quota. Now remember that in order to do this, we have to convert the percentage to a decimal. So it would be the decimal 0.014, because to convert from a percent to a decimal, we divide by 100, and then we multiply by 435 to get the 6.09. For Texas, they have 8.14% of the population, so they have a standard quota of 35.409. Now, the U.S. House of Representatives actually gives Kentucky 6 representatives and Texas 36. So you will notice that Kentucky got a little less than what it would have gotten, and Texas got a little bit more. And that's based on the apportionment method that they use to award the House of Representatives. All right, so let's look at another example. We have General Hospital has a nursing staff of 225 nurses, and they're working in 4 shifts. The average number of nurses apportioned to each shift is based on the average number of patients treated in that shift. So the nurses are going to be our seats in this case, and the number of patients being treated would be our population. So first, let's find the standard divisor and explain what it represents, and then find the standard quotas, the lower quota, and the upper quotas for each of our states. So the standard divisor is going to take our total population, 2,700 in this case, and divide by the total number of seats, or 225. So our standard divisor is 12, and that is that each nurse is responsible for taking care of 12 patients. So to find the quotas, we then have to go to each state and find each state's population and divide by the standard divisor. That's going to give us the standard quota for each state. And you will notice that if we add all of these standard quotas together, we're going to get our total number of seats to be apportioned. Because remember, that's what a standard quota is. It tells you how many seats each state should receive. So now the upper quota is going to be this standard quota rounded up. So 73, 86, 51, and 16. And notice that that gives us a slightly higher number of total seats. And that's okay. That's what we expect. And the lower quotas are going to be the standard quota rounded down, which is going to give us a slightly lower number. And again, that's okay because that's what we expect. However, if we give everybody the upper quota, we have too many, and everybody the lower quota, we have too few. So how do we evenly divide them without a surplus or a deficit? And that brings us to the keys of our apportionment. So we have standard divisors and we have modified divisors. We'll have some methods that will use standard only and some that will use both. We can round up, round down, conventionally or geometric. And almost all of the apportionment dilemmas involve finding an appropriate divisor and using different rounding rules. The divisors are used to form quotas that are then rounded, producing the appropriate division of exactly n assets. And we'll look at those methods in our future